All right, so we have another integral that has infinities. So if you see that you have a negative infinity and a positive infinity, so infinities on both limits of integration, this must be done. It must be broken up into two integrals. So you get to pick what number A in between that you get to break it up at, but you must break it up into two integrals and then go figure each of them out separately to find out whether they converge or diverge. So if they both converge, then you add them together, and that's what the whole integral equals from negative infinity to infinity. If one of them diverges, let's say this integral from 0 to infinity, or I'm sorry, from a to infinity diverges, then I know the whole thing will diverge. Because if part of it is equal to infinity, the whole thing is going to add up to infinity. All right, so here is an example. So here's negative infinity to infinity. So your first step is to break it up at some number, and I'm going to choose 0. You get to choose whatever number you like. I like 0. Okay, so we have to do them separately. So I chose this as part 1. You don't need to go label it anything, but you just need to go show I'm starting with this one. You cannot do them both at the same time beside each other. So you have to do them separately. Okay, so here we go. So first thing, rewrite it as a limit. Put the t where the infinity was, and then you recognize how to do this integral. You recognize this is arctangent. So recognizing its arctangent, carrying the limit along every single time. And then I'm going to plug in 0 and t. So top limit of 0 plugged in. Arctangent of 0 is 0. Subtract off, plugging in the t. All right, so now it's time to plug in negative infinity. So you know this is the graph of arctangent, where this is the horizontal asymptote of pi over 2, and this is the horizontal asymptote of negative pi over 2. So as I'm going to negative infinity, right in here, negative infinity divided by 2 is still negative infinity. So arctan of negative infinity is negative pi over 2. So don't be writing anything, you just think it. This negative 1/2 in the front carries along. So there's the 0, subtract, right? So these two negatives make a positive, so I get pi over 4. Okay, so the first part adds up to a number. Okay, good. And the reason I'm saying sad face is because you got to go do the second part. If you had gotten infinity here, we would have been done. So this is double the fun, right? You get to do 2 problems in one. So here's 0 to infinity. So I just took the antiderivative, and there's the t, and there's the 0, and I'm letting t go to infinity. Then I'm going to plug in the t and subtract off, plugging in the 0. So now this time when I'm putting in infinity, I have infinity divided by 2, which is infinity. Arctangent of infinity is pi over 2. So then I have 1/2 times pi over 2 gives me pi over 4. Okay, so that's what the second part equals. So I get both parts equaling pi over 4, so the whole integral adds up to pi over 2. So this, I guess we could just say, converges. All right, so let's begin looking at type 2. So type 2 of these improper integrals, now we're going to be looking at vertical asymptotes. So when the integral comes at you, you're going to see numbers a and b. What? So you're going to have to figure out where is it that it's discontinuous? Where is there a vertical asymptote? And where do we get vertical asymptotes from? Where the denominator equals 0. So you have to be aware. You'll get the cue that the question will say, does this converge or diverge? So let's look at this one, converge or diverge, and then you'll see this. So you're looking at that thinking, there's no infinity here. How come I'm being asked if this is convergent or divergent? Where's the infinity? Oh, right. This must have a vertical asymptote. So you need to know where the denominator is 0. So looking at 1 over x squared, I know there is a vertical asymptote at x equals 0. So that means I need to rewrite this as a limit. So let's even just get the picture going. 1 over x squared looks like this. So I'm being asked to find the area from 0 to 2. So this is the infinite area part here. So I'll be taking the limit as t goes to 0 from the positive side. So you have to put the t in where the vertical asymptote is. So then you carry this along, you take the antiderivative of x to the negative 2, you get negative x to the negative 1. I'm going to plug in the top limit, subtract off the bottom limit, so I get to here. So now I'm looking to plug in t equals 0. Oh, I get 1 over 0. That doesn't exist. So that means this integral diverges and this area cannot be found. So the infinite part just happens to be going up instead of the sideways with the horizontal asymptotes. Okay, here's another example. Converge or diverge if convergent. So again, you're getting this as a Q, and I see numbers here. There's no infinity, so I know I'm on the lookout for a vertical asymptote. So let's do it. How about looking at that denominator? Looks like when x equals 3, there is a vertical asymptote. So that's my first step. Take the limit as t goes to 3. So how do I know I'm coming from which side? So since the integral is from 2 to 3, and I'm taking the limit as t goes to 3, I'm coming from the negative side, or from the left-hand side. So that's where the negative comes from. So it just depends on the interval that you're looking at. Okay, so rewrite it as a limit. Put the t in where the vertical asymptote is, so the 3. You're putting the t in where the 3 was. And you're taking the limit as t goes to 3 from the negative. And then this one needs u substitution, so I let u equal 3 minus x. Du gives me negative dx, so I get a negative du, right? Negative du is dx. And then I have the 1 over the square root of u. So this you know is u to the negative 1/2. So I'm going to add 1 to the exponent, u to the 1/2, divided by 1/2, or times 2. So I'm carrying everything along, and now you remember you must put the x's back in. So I've got my x's that I put back in to here. Now I'm ready to evaluate my limit. So I put the t in, subtract off, and it's negative, negative, so it makes it positive. Put the 2 in. And now I'm looking at plugging in 3. So it doesn't matter that it's coming from the negative. If I'm plugging in 3, I get 3 minus 3. Oh, that's root 0. That's 0. And so all I'm left with is 2. That means this integral converges.